Hey robot, engines ahead full.
Copy full ahead.
Hey robot, starboard, steer 180.
Copy starboard 180. Steady on 180.
Well, hello there. So today I will be showing you a project I've been working on. It's the first step in a research project that I think has good potential for collaboration and for further work. The idea is to do voice communication with autonomous vessels. So the idea is that the main communication method between ships is VHF radio. People on ships talk on the radio to each other to communicate ship to ship, to talk to the vessel traffic, and whoever else needs to talk to the ship. So what if autonomous boats could also use VHF voice communications? So here we see an autonomous boat I've worked on called Dumbo, the orange boat in the foreground, and the ship at Cal Maritime, the Golden Bear. So it would be nice if the Golden Bear could communicate with Dumbo using the radio. And the nice thing is that a lot of this technology exists already. If you have an Alexa or a Google or a Siri device, they all are voice communication devices. So we're going to apply this technology to autonomous boats. And the one constraint that is important to consider is that most of these Alexa and Google devices, they sit and wait for their wake-up word without using any kind of data connection. But once they get the wake-up word, "Hey Google," then they record the sound and send that off over the internet to be interpreted. But that would be pretty inconvenient on a ship at sea to have to connect. We're trying to use on off-the-shelf packages, but not relying on an internet connection. There are some advantages to using a marine VHF radio communication compared to something like a regular home assistant. And that is that the way you're supposed to talk when you're communicating between ships on a VHF radio is using these standard marine communication phrases, the SCMP. They are published by the International Maritime Organization, the IMO, and there is a useful subset of phrases. So if we have to train a computer to understand English, here we have a limited subset of English phrases that the computer has to learn. There are a few disadvantages to doing voice communication on ships. Radio noise is a big one. Radios aren't very clear all the time. There can be background noise, engine noise, and compared to the usual way you communicate with autonomous vessels, which is with a telemetry link and a ground control station, voice communication is very slow. So if you need to do something in a hurry, it might take a minute. You might have to say it twice. So that is something to consider when you're doing voice control and autonomous vessels. So for this demo, we're going to use some of these standard marine phrases, and from the documentation, I've implemented this steering to heading command, where the commander says the direction to turn, port, and then the heading to hold. Port steer 182 means turn to port until you're on a heading of 182 degrees. And on receipt of the order, the helmsman should repeat it and bring the vessel round steadily to the course, and when the vessel is steady on the course, the helmsman is to call out "steady on" the heading. The other phrase that is implemented in this demo is to control the speed. So engines full ahead, engines half ahead, these are the standard way to control engine speed. So for the demo you're going to see, the autonomous vessel is a simulation. So I'm running a autonomous boat simulator on a virtual Linux machine, and it's running the ardupilot software in the loop simulation. That's the SITL. And so you'll see this screen, and that is the simulation of the boat. To control the boat, we have the usual ground control station. That's the mission planner program shown here. And we can see what the boat's doing with the mission planner, and we could control it the usual way by clicking on commands and buttons. But in addition to that, there's going to be the voice command software, which is written in Python, and this would be run on the actual vessel, and it's running on the same computer as the simulation is running, and we will see the command line of the Python console. And then we will have the person making commands talking to the voice command software. All right, so let's see how it works. So here is the virtual machine that we're going to run the simulator on. It's the ardupilot simulator, and it has a lot of options. So I've got the commands all boiled down here. We can see the command I'm using is simvehicle.py. The rover vehicle, I've got two outputs on the IP addresses, one going to the mission planner program and one going to my Python program, starting it at this location, latitude and longitude, so that it'll be in the waters off of Cal Maritime. So let's start that up. So this takes a minute. It has to initialize some things, and then it fires up the simulator, and then the simulator has to initialize some things. And we will wait till the GPS is acquired so the autonomous boat is ready to go. It's getting there. That's probably pretty good. So now the autonomous boat has been launched and it's running. Let's connect to it with the mission planner so we can see what the boat is doing. Okay, so the boat is connected. So here is the boat off the water of Cal Maritime. You can see the scale of the boat changes based on the zoom. So this is just a representation of the boat simulation. Here is the heading of the boat, the speed of the boat. This is the throttle in various units. Okay, so let's start up the voice command now. That is this program. So this is my Python code. And what it does is it waits till it hears a sentence from the speaker. And if that sentence has the word robot in it, that's my wake-up word, ship's name is robot, then it looks for things like the word steer or the word engines, and it parses the information to figure out the command. So I'm going to run that, and we'll see over here what's going on.
Waiting to hear go robot.
So this is the report from the boat of its heading and speed that the Python program could run. So this will be running on the vessel, and right now it's running along with the simulation of the vessel. So if we put the mission planner up here, then we can try it out. So let's see how this works. Hey robot, robot, engines ahead half.
Copy half ahead.
Hey robot, port, steer 270.
Copy port 270. Steady on 270.
Hey robot, engines ahead full.
Copy full ahead.
I'm going to try to dock with the golden bear down in the bottom of our screen. So I'll head it south and then slow down and turn. Hey robot, robot, steer port 180.
I did not understand. Did you mean to say steer port 180?
Hey robot, port steer 180.
Copy port 180. Steady on 180.
So you have to say port before steer, not steer port. I get that backwards sometimes. Hey robot, port steer 110.
Copy port 110. Steady on 110.
Robot, engines ahead slow.
Copy slow ahead.
Robot, starboard steer 115. Hey robot, starboard steer 115.
Copy starboards 115. Steady on 115.
So we're almost there. Hey robot, engines stop.
Copy engine stop.
So we've maneuvered alongside the Golden Bear. Let's see if we can get back inside the harbor and stop one more time. Hey robot, engines ahead full.
Copy full ahead.
Hey robot, starboard steer 180.
Copy starboard 180. Steady on 180.
Hey robot, starboard steer 300. Hey robot, starboard steer 300. Hey robot, steer 300.
Copy E300. Steady on 300.
Hey robot, starboard steer 000. Hey robot, starboard steer 000.
Copy starboard 000.
So you can see the wake up word.
Steady on 000.
The wake up word needs to be repeated sometimes. Hey robot, starboard steer 090.
Copy starboard 0.
Hey robot,
Steady on 000.
hey robot, starboard steer 090.
Copy ready on 000 as starboard 090.
Bunch of things in there.
Steady on 090.
Hey robot, starboard steer 160. Oh no.
Copy starboard
Yay.
160.
Hey robot,
Steady on 160.
Hey robot, engines ahead slow.
Copy slow ahead.
Now it's going to take too long. but we'll give it some time to get into the harbor. So we saw some repetition necessary. Sometimes it didn't recognize the words. If you pause too long, it will take what you said and try to process it, even though you weren't finished. But overall, with some practice, you can make it work pretty reliably, especially if you have time to say things twice. Hey, robot, robot, engines ahead, half.
Copy half ahead.
So the ship lies at about 110 degrees, so that's my line up with the dock angle. So we'll let it get in, and then we'll turn to that, and then we'll go dead slow. Hey, robot, robot, steer 110.
Copy 110.
Hey, robot,
Steady
robot.
on 110.
Hey, robot, robot, engines ahead, dead slow.
Copy dead slow ahead.
This is actually a speed command of 1/4 meter per second. This you can double this, and it's the speed in knots. 2 times meters per second is knots. So we're going about 1/2 knot ahead at dead slow. Hey, robot, robot, engine stop.
Copy engine stop.
All right, so that's the demo. Hey, robot, quit.
Robot out. Goodbye.
Okay, so that was the demo. It's working pretty well. A few obvious things to add would be if we were using an actual VHF radio, you wouldn't want anyone to be able to command your ship. So the software that I'm using actually has a voice fingerprinting, so it can detect who is speaking. So you could use that for one layer of security. It would be interesting to interface it with other autopilot hardware. So I'm using the ardupilot autonomous boat system here. But if you were a single-handed sailor and you fell overboard and you happen to have a radio in your pocket, it'd be nice to be able to command your sailboat to come back to you. And it would be nice to add this into an actual ardupilot boat. This exact software should work on an ardupilot boat using an actual radio link to see how that works. This software should run on an embedded system like a Raspberry Pi that we could put on a small boat and connect to it with the radio and navigate. It would be also nice to get a status report over the radio from the boat of its battery voltage, GPS status, other things like that, and maybe negotiate traffic. We could have it hold its position if needed. And it would be also interesting to collaborate with some of the maritime faculty at Cal Maritime to see what would be used in practice and how these phrases are used in the real world, since I was just going from the publication. We could also have a custom speech model. If we recorded actual VHF communications, we could transcribe them and create a reference data set, and that would be useful for extending this work even further. Well, thank you for watching, and if you have any questions, put them in the comments, or you can contact me from my email at the Cal Maritime webpage. See you later.